So this is what's called the standard algorithm for division. And it really does just consist of successive guesses. However, our successive guesses are going to follow two rules. First, each guess has to take the form one digit followed by some number of zeros. And that's an easy rule to follow, right? Because those are the easiest kinds of guesses to do the multiplication with. And the second rule is each guess must be as large as possible without going over. Right, and we'll think about how to accomplish that. But the short version is we just check all of the possibilities. So I'm going to use this guessing method, but not quite the standard algorithm to solve a problem. And then I'm going to show you how we write out the standard algorithm. Let's say we want to work out 7,921 divided by 9. So again, we're going to start with a division bracket. So my first guess is going to be a single digit followed by some number of zeros. This is a 4-digit number. Will a guess of 1,000 work? Will a guess of some number of thousands work? Well, no, because 1,000 times 9 is 9,000, which is too big. So my first guess is going to be some number of 100. And when I multiply, I'll get 2 zeros at the end of some number. So that means the 2 and the 1 and the tens and the ones place, I don't really need to think about those when I'm coming up with my guess. I only need to think about the 7 and the 9 in the hundreds and the thousands place. I can think of this as the number 79. Let's see why. I look in the table in the row labeled 9. I find the biggest number that's smaller than 79, and here it is, 72, in the column labeled 8. So my guess is going to be 800. I have 8 times 9 is 72, so 800 times 9 is 7,200. Of course, I subtract. 1 minus 0 is 1. 2 minus 0 is 2. 9 minus 2 is 7. Right? And now, the way that I can tell that 800 was the right guess is that I have less than 100 times 9 things left. I don't have enough hundreds left to guess another 100, so I'm going to guess a 10 instead. So my guess will have a 0 as its last digit. The number of things I use up will have a 0 as its last digit. I really only want to be thinking 9 into 72. Again, looking at the table, I find 9 goes into 72 exactly. It goes in exactly 8 times. So I have only one thing left over. Adding these together is easy. 800 plus 80 is 880. And my remainder is 1. Now looking at this process that we've just done, we notice that there's an awful lot of repetitive writing of zeros and a lot of copying down of numbers that we aren't really interested in. How else could we work a problem like this? All right, so let's work this again. 9 into 7921. Now the first thing we did was decide that 1,000 was too much. And all we needed to see for that was the 7. 9 doesn't go into the 7. So what do I have here? I have 0. Now I turn to the next digit, 79. Right, there are 2 zeros off to the side there, but I'm not really interested in them right now. 9 goes into 79, we said earlier, 8 times. 8 times 9 is 72. Subtract, and there are only 7 things left. Now invisibly, we have some zeros here, and we're subtracting. But I think that for my next step, I'm only going to be interested in the 2. So now I have 9 goes into 72. Well, again, that'll be 8 times. Using up 8 times 8 is 72, with 0 left over. Now I uncover another place. And again, remember that invisibly, the 1 was here. There's a 0 here. I'm taking 1 minus 0 is 1. But the way that I think of that as is I bring down the 1. Now 9 goes into 1, not at all. 9 goes into 1 0 times. 0 times 9 is 0. So I still have 1 thing left over. So what's the procedure here? We're only looking at a few digits of the dividend at a time. So what do? First, we uncover places until we see a number larger than the divisor. Then, using the multiplication table, we make a guess at the quotient. We decide how many of our initial group are used up by multiplying the new digit times the divisor, and then subtract to see what's left. And then, then we move on to the next digit, right? We bring down the next digit and go back up to this step. When we run out of digits, what's left is the remainder. Let's try 4,522 divided by 5. I'll write a division bracket and fill in some columns so I can keep track of my place values. Here's my multiplication table. I cover up the columns. 4 is smaller than 5. 45 is bigger than 5, though. How many times does 5 go into 45? 5 times what? Oh, I see I get exactly 45. 5 goes into 45 exactly 9 times. 9 times 5 is 45, and there's nothing left. Am I done with this problem? No, I still have lots more digits. I'll bring down the 2. 5 goes into 2. If I have 2 things, I can't make any groups of 5. 5 goes into 2 0 times, and 0 times 5 is 0. Now I subtract. 2 minus 0 is still 2. And I bring down this other digit. Now I want to see how many times does 5 go into 22. In the 5 row, the biggest number smaller than 22 is 20, and that's 4 times 5. So 5 goes into 22 4 times, using up 20 things, and 2 is left over. Since I'm out of digits, this is my remainder. Now I'm going to give you one of these to try. Evaluate 782 divided by 4. Pause the video and try this now. Alright, so first we're going to set up the division bracket. 4 into 782. So 4 does go into 7, doesn't it? Only once. 1 times 4 is 4. We have 3 left. Bring down the 8. 4 goes into 38. Oh, I see it goes in 9 times, using up 36 things, with 2 left over. Over again, bring down the 2. 4 goes into 22 5 times, using up 20 things, with 2 left over. And so, since I'm out of digits, my remainder is 2. My quotient is 159, and my remainder is 2.